Cool. Thank you so much. Thanks everyone for coming out. This is great. They asked me yesterday to do this, so apologies in advance if I'm completely unprepared. But I have an amazing set of panelists here. I'm Lawrence van der Maten, worked on a lot of different things in the most recent years at Meta. Currently working on Llama. Joined by Joe.
Yes, hi. I was actually asked to be on the panel a week ago, so I had slightly more time. I'm a professor of computer science and data science at NYU, really the neighbor here. And I also work as a senior director of frontier research at Persian design team at the Genentech, which is a part of Roche as well, working on the computational antibody design. And I'm actually a bit surprised and disappointed that you did not mention t-SNE. Lawrence, how can you do that?
Well, but you didn't mention attention, right? So, I'm Sasha Rush. I'm a professor at Cornell Tech on the F train on Roosevelt Island. On the F train, it's easy to get there. You take the gondola too, but the F train's much easier. And I work on NLP, and I work at Hugging Face as well, excited to be here.
Hi, I'm Leland McInnes. I work at the Tut Institute, which is a research institute in Ottawa, Canada, so I guess I have the longest trip to get here.
He lived right there. He fell here.
Most of my work is in triaging through really, really large data sets. So I'm an advisor for Nomic, looking at ways to visualize, cluster, and explore really large data sets. My research work includes the UMAP algorithm for dimension reduction. I wrote implementations of the HDB scan algorithm for clustering. So if you know those things, that's great. If you don't, that's okay too.
Awesome. Thanks for the intros. Maybe this is also a great segue into sort of one of the key topics, I think, in a lot of AI developments right now, which is sort of around data. And one of the questions we got from a lot of you is to get this panel's perspective on where the remaining opportunities for advancements in large language models lie, given that we've probably downloaded most of the internet and are already training on it. And so I'm curious to get your take on this. Maybe Sasha or Joe, do you want to kick us off on this one?
Yeah, that's a good question. I think I was arguing with Jan LeCun about this on Twitter the other day. I think his take was that people...
You and Ellen.
Yeah, right. I'm meeting Elon. I think Elon Zephyr on the wrong side. We're both there. Yeah, he was being a jerk. Anyway, sorry. We'll get into there. No, but I think Jan was arguing that people in academia shouldn't work on large language models, whereas I think I'm pretty bullish on academics should study this topic. And I think maybe the difference is that the kind of feeling is that companies have this. They have so much money, they're going to train the biggest models, do the most work. But my feeling is that they're being extraordinarily conservative. They're training exactly the same thing in exactly the same way in a kind of bigger and bigger scale. And there's so much money on the line that it's actually very hard to take chances. And so, I guess there's one sense that we found it, we figured it out, it's perfect. But I think, I don't know, there's a huge risk that we're just going to run out, that data will stop being useful, we'll have to come up with better algorithms, we'll have to figure out other ideas. And I think there's a lot of opportunity and a lot of leverage if you can come up with something new. Yeah.
Can you tell us about your bet and how do you feel about it now?
Yeah, right. So I have a bet with Jonathan Frankel, who I don't think is here, but both of us are New York Tech, so it's awesome in that regard. So the bet was made about 5 years ago, 2021, during the pandemic and a little bit of Twitter madness, where I made a bet that within 5 years, someone would come up with a model that would beat Transformers. So Transformers had dominated NLP for 5 years. It came out in 2017, BERT was 2018, T5 was 2019, GPT-3 was 2020, and then it's just been exponential growth since then. And I was like, well, in 5 years, some new idea will come along. we're 3 years into the bet, and I am losing miserably. And my understanding is that they may have already planned their next model, so I may have already lost in some sense. Someone came up to me at a party the other day and said, do you think they'll tell you if they use something different? Which made me really worried that maybe there was something else going on. So maybe we'll find out in 20 years that I was right. I'm going to hold on to that. But there's a ton of interesting work going on in different alternative models. Lots of really interesting new developments, new LSTMs, Mamba models, all sorts of linear attention approaches. So lots of really cool research came out of kind of thinking about different ways to train language models in different styles.
Cool. So like, you know, llama is still a transformer. You know, don't worry.
But llama what? Okay.
Yeah, wait, can you show me the 400 billion one? Yeah. I don't believe you. Maybe it's not. It's not.
Patience is a virtue.
I want it now.
Obviously, like data, you know, data quality is a big driver for these models as well, Leland. You've been working a lot on sort of large scale data sets and so on. What do you have any thoughts on that? Like, what can we do to like further push the quality of some of the data that we're training on in LLMs and more broadly in AI as a whole?
Yeah, I think data quality really is critical. I think there have been some very recent papers that have put forward the idea that at the end of the day, it's actually just the data set, not the model, that really matters. All the different models, whether it be a transformer model or something entirely different, ends up converging to essentially producing the same sort of output as long as you give it the same sort of data to train on. So the real question is, what data are you using to train with? And using all of the internet is probably not a great idea. There's a lot of unpleasant stuff on the internet, but there's also just things you probably want to weed out for any sake. So I think actually big advances are going to come in our ability to dig through these data sets that are too big for us to look at in any other reasonable way and distill out the ideal data for building a model that solves your actual problem and tailoring the data to the problems you have. And I think that's a real problem that isn't being worked on as much yet, but is definitely going to be coming very soon.
Joe, you're shaking yes a lot.
Yeah.
Care to comments from the biological side of things?
Yeah, absolutely. Actually, data is really the key. And then at Prescient Design, we've been actually running a lot of experiments. That is not just computational experiments, but synthesizing all those antibodies and testing them for their various properties. And then we've gone through this process, what we call lab-in-the-loop design process for the now 13, 14 rounds during the past, let's say, 3 years. And then what we do see really is that the algorithms do matter, obviously. If the algorithms are not there, it's not going to work. But what really matters is what kind of data and how we are going to measure them, and then how we are going to accumulate them in a way that allows us to actually explore further and further. And then what that means is that the data collected without purpose always has a limited utility. At some point, in order to really maximize the utility of whatever the data you have, you need to really start collecting data with the purpose that you know. And then that's the only way for all of us to go beyond, way beyond what we have done so far as a humanity. So finding a new molecules that's going to treat some of the disease that we've never even imagined treating. We are not going to just look at the internet and then try to interpolate among all those text that has been written down. We'll have to go way beyond it. And then to do that, we have to actually incrementally but surely collect more data with purpose. So, yeah.
Is that at odds with the idea of foundational models, sort of like models that can solve any problem if you throw enough data at it?
I know. So we almost always do that just for fun. We open up the ChatGPT and then ask it, so here's a target antigen for which we want to design a new antibody. And then this antibody has to be very different from the existing antibodies. And then we're going to give them even some examples and ask it to now design antibody for us. It's going to actually give us something. Well, nowadays it doesn't. It's going to tell me to actually study biology and then figure out how to design it, unfortunately. But now, before, it used to actually give me the amino acid sequences. And then, of course, if you have it, we can test it, we can synthesize them. And then now, from there on, we need to ask ourselves questions. Are we actually ready to inject that directly into our body? No, I'm not going to do that. No one should do that. In fact, no one should even think about doing so until we actually do all those experimentation in order to make sure that these are the reasonable antibodies that can be therapeutic down the road. And doing all those things actually require us to collect more data. So it's not really about just let's use all the internet scale data that others have collected for us. Hooray. No, not like that. We have to think about how we collect the data as well from the very beginning. It is on.
Turn it up. More volume.
I think
Okay, closer.
just put it closer.
Yeah. Lawrence, can we actually ask you this question?
You can.
I think there may be two things I'm curious about. One is what technologies you think are useful as part of the data process for pre-training, and then also maybe what the kind of like sense of what the job is. Like, who should we be training? Someone who's like really good at data. What are the kind of skills that you'd want?
I think, like, to start with the second question, I think a mistake I often see researchers make is that they don't look at their data sort of enough, right? Like, you really kind of, I don't know, need to like wake up and go to sleep, like thinking about like what are all the ways in which my data can be messed up, and sort of like, you know, do endless iterations of like filtering, training different quality classifiers, thinking about like, hey, what would matter, what would not, doing experimentation on like sort of like what is the effect of like different data mixes and so on, like on the final sort of output of your models. And sort of as part of that, like also like thinking in a way full stack, right? So not just thinking about data, but also thinking about like what is the thing I'm trying to optimize for, and how do I evaluate that? Like how do I measure success quickly, and are then able to iterate quickly. I think in terms of like, to answer your first question, I think in terms of like pre-training data quality, there's still a lot of work we can do, right? Like, you know, to Leland's point, like if you start with downloading the internet, you know, it's not really like the best thing to be reading, right? And so you need to figure out like, hey, how do I sort of like filter this down, distill this down to like a set of data that really gives me what I care about, right? Which is sort of knowledge about the world and reasoning capabilities and, you know, biological knowledge and sort of like everything else that's sort of important to the goal of my project. And then, you know, the other piece is like there's sort of two parts to data, right? Like the pre-training part is one, but then the, you know, sort of like data that you collect in post-training, Joe called it like lab in the loop. I think in LLMs it looks more like human annotator in the loop, right? Is super important, right? And is where a lot of capabilities are really sort of like integrated and made successful in these models, right? So like if you think about things like reasoning or coding, like yes, pre-training matters and skill matters, but like where you really drive performance on those tasks is in post-training. And so there it's about very sort of like careful experimental design and sort of thinking about like how can I spend my annotation dollars best.
Can I also ask a question? Well, not only to Lawrence, but also to Leland as well, is that is it actually reasonable for us to believe that we can check the quality of individual data points without actually training a model using a collection of all those data points? Can we do that? Is it actually theoretically sensible to believe so?
Can you clarify a little?
So let's say I have a huge insurance scale corpus, and then now I want to know whether a document is really of a high quality or not. Now, without in fact training some large model on large amount of data twice, after leaving one of them out, and then really see what kind of end results I'm going to get, or the differential between those two, can I even say that any individual document is of high quality or low quality, other than the fact that I read it, I did not like it, so low quality, I loved it, high quality?
Well, quality is a very hard thing to judge in general, so I wouldn't want to put quality scores on individual documents. I think in terms of triaging through a data set or distilling a data set, it's more finding the things that are closest, as Lauren said, to what you're interested in having the model learn. So there are some things that are going to be much more important to that. You're not going to weed out everything, and that's fine too, because they learn from large amounts of data, and even data that's not hugely relevant is still useful for the model to learn and generalize. But getting more of the data that you want in there is obviously just going to be beneficial. So anything you can do, any way you can look at the data, build models, build all sorts of models, and get all sorts of results out and look at them. And as Lauren said, you kind of have to just eat and sleep the data for long enough that you have real intuitions about what's in there, what could go wrong, and how you could possibly fix it.
It's wild though. I mean, 15 trillion tokens. Like, that is so many tokens. I know how to get intuition behind like 1 million tokens, and it's really hard, right? But 5 orders of magnitude more, yeah.
I don't even have an intuition for 1 million tokens, to be honest. I think, like, just to add to Leland's answer, like, I think one part is, like, well, if you're training Llama 3, right, like, you already have Llama 2, sort of by definition, right? So you can use that, right? So you have something to start from. I do think, like, you know, the other piece is sort of, like, thinking through the whole stack, right? So like thinking all the way to evaluation, right? And then thinking about like post hoc analysis as well, where I think there's still a lot of work that can be done. It's also like to maybe sort of the kind of work that that can easily be done in academia, right? Like where you don't necessarily need to train those massive models, because it's much more about like understanding like, okay, where do these things come from, and like where are they good and where are they bad? And I think that can teach us still a lot about how to improve these models. I don't know if we're supposed to take questions. Maybe, so we collected questions, just to be clear, like from sort of the audience, or, you know, I'm not making them up, but like, I'm trying to stick to the rules, so someone will yell at me. Maybe sort of like one, a completely different topic that's come up a lot in questions from the audience is about sort of the value of open weight models. And there's sort of like two parts or two questions that come up in this. Like the first question is like, until when is it like responsible to like release models as open weights, or is there a limit where, you know, we as a community should start thinking about stopping doing that? And then two, and I think Sasha, you already touched upon this a little bit, but like, what does academia and smaller labs and smaller companies, like what do they do in a world where, you know, a lot of the improvements come from scale and sort of like as part of that investing more money? Do you want to take a stab at it first, Joe? I know you have ideas on everything, so.
So open weights, absolutely great, but not enough. In fact, I'm very bitter about Meta not releasing the training code and the data pre-processing code for I'm sorry. So from my perspective, there are a number of issues. One is that the open weights are great to the point that the Meta commits and tries to release the neural models every year to the public. Otherwise, it just becomes essentially a hook. It's a bait. So that actually makes me really, really uncomfortable using it at Roche. We actually train our own 7 billion parameter model following as closely as we can the Llama 2 recipe. We can train it. It turned out that it works really well. But there's still always a slight gap that we find, whatever we do, that we cannot just narrow. So we do use mix of our own model weights as well as the model weights from the Llama as well. All good, but this is really a bait. And then everyone is so impatient. Patience is virtue, but no one has it. So they all run to that one. And then another thing that I'm actually a bit worried is that this not releasing the code itself, training code, is in fact a way for us to slow down the innovation. So at this point, I gotta say, what is the incentive for OpenAI as well as, well, Meta is better. So okay, OpenAI's incentive is in fact to make things look bigger and untenable for everyone else. Even if they have a tiny model that works just as well, they're not going to tell us. They don't tell us. They want, actually, Sam Altman always go out there and then tell people, actually, I was in Korea, I hosted a fireside chat. He literally tells the startups and the companies in Korea that no, you cannot build it, it's too difficult, just use OpenAI. And I was like, is it really so? because OpenAI, it was back then 7 years old company with about 150 people. And then in the first, let's say, 4 years, they wasted tons of the time and efforts in building a robot arm that's going to solve the Rubik's Cube, right? Not that that's bad, that's great. That's
They're pretty good at League of Legends.
Yeah, that is great.
Pretty good.
Yes, League of Legends, yeah.
Yeah, almost one, I think.
Absolutely, absolutely. So at the moment, in fact, hiding this code and the weights is in fact a way to make everyone waste their time and then become a very, very reliant, let's say, clients, actually ship essentially, right, to these the wolves who are the OpenAI and all those companies. So yes, I think we should actually advocate for the open weights, but also the open sourcing, all the training code as well as the processing.
Get out of here. This is crazy talk. Man, this is like the biggest gift to open source ever. The cost of, if you release the 400 billion parameter model, that would be so crazy.
Oh, that's
like,
great, yes.
Like literally, that's years of open source stuff. Right? Like I think Meta's crazy, but like let's not complain. I mean,
I think Meta can and should do way better for the entire community, not the entire humanity. I would say, yes. I think Meta can do it.
I'm not going to push my luck. Just keep on doing what you're doing. I'm in. I don't know. Yeah, I just feel like it's opened up so many interesting things. And I think it's been incredible for academia. I mean, to actually have the access to the models and to have really serious competitive approaches. And I don't know. I think it's amazing and totally chaotic and sucks nuts. And yeah, I don't know.
Any doubts on your minds on because there is a lot of discussion in the community about, some of the risks associated with these models, right? And sort of these models being available in the open to arbitrary actors in the world. So so is there a point where you would, or something that you'd have to see in these models that would change your mind?
It's funny, there's so many clearly problematic things right now with the voice models and the image models that I'm so much more worried about those applications. I feel like I haven't seen the really scary stuff yet with text. It's possible that I don't have access to GPT-5 or whatever, so I'm not seeing it, but I don't know. I feel like we still have a ways to go. And I'm curious what other people think.
I think there's...
Wait, you have GPT-5? Okay.
The voice models are scary.
The voice stuff, yeah.
Persuasiveness, sycophantic, encouraging someone to kill themselves. It's that's
In text or in voice?
well, in text. So imagine.
Oh, and the text stuff is not very convincing to me.
Your voice concerns.
The voice concerns are, I think, pretty evident, spam callers, fraud, particularly of I don't know, some of these scams of extracting money or things of that form. I mean, people have been trying that with text for years. It's not that effective, but if it sounds like a voice, I mean, we're used to that kind of being synonymous with authentication. No, I just think we're hard-coded to think of that as trust, voice is trust. And
It's already bad with text. People have committed suicide at the behest of text models. There's citations in some DeepMind papers about persuasiveness, but this kind of thing is really happening. And then if you look at character AI, people use it 2 hours a day.
we can argue about this. I'm really pretty unconvinced. I mean, the examples they continue to bring up in these papers are extremely silly. The biological threat risks are really
Less mundane. It's just
Yeah.
asking someone something very simple via text.
yeah.
It doesn't have to be, it copies itself across the internet or it creates biological weapons. It's just convinces someone to, maybe they should commit suicide. That's happened with just simple open source fine-tuned models.
I need some citations on this. Okay. I'm happy to look at it. And I'm not saying there's zero risk, but certainly I've been I mean, since GPT-2, OpenAI has been really hammering the red alarm on this stuff, and it really hasn't come to fruition in anywhere near the scale that they've been claiming.
I think it's fair to say that there are a lot of different opinions on on this stuff, and so great topic for conversation. I think after this panel as well. How are we doing on time? About 5 minutes. There were 2 parts to my question. One was sort of about some of the risks and safety issues potentially with open weight models. The other question was sort of in a world where, these models become ubiquitous, what are, sort of like if I'm a researcher in an academic lab or a smaller company, what am I supposed to do? Like, what should I be working on? Joe, you have like a ton of research ideas, I know, so maybe you can kick us off.
I'm going to wear the Jan LeCun hat. Probably LLM is the last thing that people should work on, but okay. But that aside, I think the amazing success of these large-scale language models as a conversational models and whatnot is actually blinding us from the fact that there are so many more interesting problems than building an amazing interactive, let's say, language-based often, let's say, systems. And I think that it's so blinding to the point that we are talking so much about the problems that are in front of us while not realizing that there are so many other problems out there. In fact, it's blinding to the point that I talked with some of the people at OpenAI, and then I wanted to recruit them to Prescient Design, to work on antibody design. We can really, literally, down the road, we can save some of the patients' lives, or they make the patients' lives better. Often the response I get is that they're going to find the AGI, build the AGI at OpenAI, and then ask AGI to solve the drug discovery. No. So yes, so many other problems. We just need to be slightly less blinded by this trend.
Leland, you're also not training LLMs? What is your take on this? What should people be working on?
So I think one of the things that's being a little bit slept on that's in the same realm is the encoder models of these things, like sentence transformers from Hugging Face and all the encoder models, because they empower all sorts of things that we can now do with unstructured data generally. And yes, the natural language interface that comes with the generative models is really powerful, but I think there's a whole lot more that can be done with the encoder models and just vectorizing the vast troves of data that we have and applying just classical techniques. I mean, if you look at retrieval augmented generation, which is what everyone does, the real power of that, a lot of that is information retrieval. That's the workhorse, and then the generative model does a great job on top of that to turn that into a natural language answer that answers the question. But there's a lot of information retrieval that's like classical problems there that I think there's a lot of work to be done in that. And I think there's still a lot to be done in that whole realm away from the generative models.
Well, I'm going to be like the troublemaker on this panel. So I have a different take, which is I'm a language maximalist. I actually don't think any of this other stuff matters, and I think retrieval augmented generation is pretty much a Band-Aid. And like, if I was starting a company and I had to get a product out in a year, I would totally do it. But I don't think it's interesting, and I don't think it's important. Like, I think eventually we'll have models that just are retrained every day. They pull all that stuff into their weights. They have extremely long contexts. Like, I think we're not thinking far enough ahead of what, say, 4 more iterations of NVIDIA, I don't know, Z2000 models, and like what that kind of compute. And I think we have to be thinking about this like Moore's Law. Like, we're at the beginning of this. It's going to get faster. It's going to get bigger. All this stuff right now is just the kind of first generation. And like anything that feels like it's a Band-Aid, like, is not going to last in these kind of systems. I also think language is really important because it's not just a modality. It's a way to instruct other systems. Like, you can't just train a model on code and expect it to be good. You need to train it on code and language so that you can specify what you want it to do and how you want it to work in these ways. And again, we've seen that like language helps other modalities, but we haven't really seen the opposite so much. Like, adding images doesn't really help a language model, right? It like gets better at image generation, but doesn't get better at reasoning, right? So like, I don't know, I think language is really cool. I mean, obviously I'm biased, but why not? So, yeah.
So Sasha, I've been using Nomic embedder via Hugging Face to embed all those PubMed articles. Should I stop doing that?
No. No. I use retrieval augmented generation. I think we should use all this stuff, but maybe the question was kind of like, what should academia think about? And I think academia should be pricing this in, right? Like, where is it going to be going as opposed to where it is now? Yeah.
Cool. On that note, let's thank our amazing panel.
Alrighty, we'll make a quick transition to welcome the innovation panel, where they'll be talking about all of this in practice and how we apply it at places like Nomic, ThrivePal, and Hugging Face. So without further ado, I'd love to welcome the next panel. We have Elon, Brandon, Victor, and Grace. And Grace will be moderating this panel between the various startups here.
All right, can everyone hear me?
Can you? Yes.
Well, that was an awesome panel, and what a great place to build on as we talk about all of these very contentious but also really exciting research topics and how we're using them in production. Have an incredible group established here, and maybe as part of the first question, just quickly introduce yourselves and what you're working on, but I'll throw in a first question with it as well. What is the most common stack you are seeing today? We have a ton of different tooling. We're seeing some people doing training and inference in-house, not in-house. What are they using? What are the most common tools you are seeing, cloud provider, et cetera? And then we'll get more into it from there. Victor.
Cool. Victor, I'm part of Hugging Face, part of the science team there. I've been there for a while. So worked on...
What number employee were you at Hugging Face?
Number 2 or 3. So worked on the open source, kicked off the whole like open source division at Hugging Face, and mostly working on science these days, multimodality especially. So what's the most common stack that we were seeing? I guess there are different parts of the stack between data, training, inference, model deployments, and stuff like that. And I can list a bunch of like tools that a lot of people have been using. On the data side, I think like we're clearly missing a tons of things, but Lilac, Nomic, Argila, I think have like pretty good traction and pretty good usage. On the model training side, I think Hugging Face is like building a lot of these tools, and like at the very high level, like the Hugging Face hub is really like this place where a lot of this stuff are happening, and like building on top. Like model sharing, dataset sharing, but also all the libraries that are surrounding this Hugging Face hub. And I guess like what, at a high level take, what I would say is that like having a unified stack is great, and like consolidation is great. From a user perspective, I would want to nuance that. Like as a user, I would want to use the tools that I think are the best and are the best for my use case. And so I think from this perspective, modularity is like probably like the trade-off you want to strike here. You want like unified stack, but you also want to use the tools that you like. And from this perspective, I think interoperability is like probably the most important. You want like tools that you like being able to interact with other tools that you also like. And so Hugging Face Hub like plays this role of integrating a lot of these open source projects like Llama CPP or like I don't even know, like DuckDB on the dataset side. Yeah.
Awesome. Hey everyone, I'm Brandon. I'm the co-founder and CEO at Nomic. And on the stack side of things, I'll just start at pre-training. I'll go through from there. So data curation wise, like a lot of people just don't do anything. Yep. And they need to be. I mean, I think the last panel made that very clear. Obviously, I'm a little biased, but I think they should use Nomic Atlas. But Lilac is also really, really awesome, and Nikhil's really smart and good at what he does. So that's a great option as well. And like seriously, if you're gonna do something, like at least make like a matplotlib visualization or like Plotly or like anything. And then on the training side, I think we see the dominance of CUDA right now and just like the NVIDIA pipeline. And so in the same way that Sasha is maybe a language maximalist, I'm sort of a flops maximalist. And I think that's going to continue. On the sort of model sharing side of things, I mean, Hugging Face is the place. In terms of the RAG side of things, I think, in the open source, Llama 3 by far is the most popular thing we see in GPT for all, which is one of the Nomic offerings. It's sort of an open source ecosystem of language models. And also on the RAG side of things, I think Nomic Embed, I'm very happy to say and very proud to say has become quite popular. I think it's just outside the top 10 most downloaded models on Hugging Face now. I was hoping we'd crack top 10 by today, but we're at 11, so help us get there. And then on the compression side, Llama CPP, what Gergie's doing there is great. And I'm also proud to say, Nomic's been able to give back to that repo and contribute some code upstream. So shout out to the people at Nomic that are working on that. And then on the inference side to end, I think for a long time, Triton has been kind of the de facto way to do this. But now we're seeing these like specialized inference providers, the base 10s, the fireworks, and so on and so forth, the replicates coming into play and really putting together great teams to optimize these models for inference. So we'll see that. I also want to shout the Sens transformers and the web folks over at Hugging Face doing a great job at getting these models on the edge. I think, with web GPU, we're going to see a lot more of that in the coming years. So excited to see that stack kind of grow out.
Hello, does that work? Yeah. Hi everyone, my name's Ilan. So my company ThrivePal, we do personal development. Before that, for 8 years, I was actually with Lawrence at Meta at Fair. So I love the answer you gave about the stack. What I would say also that's super important for people, founders in general, to think about is that there's really strength in numbers. So it's often, sometimes people think, what's the stack that's the best for my use case? But then you kind of lose the whole huge benefit of community, because these are technologies that are changing very fast. And if you pick something that's popular, there's going to be a lot of support, and there's going to be lots of people trying stuff and running through walls that you'd rather avoid. So it's better if someone else took the wall before you did. So sometimes it's better to take like something that's not perhaps exactly optimal, the best performance on what you think is your best benchmark, which, that's a whole other topic that often something that looks like a benchmark that's suited for your kids is actually not exactly what you need. It's very hard to evaluate well. But one thing that you can know for sure, so I would say evaluation is hard to do well. What cannot lie usually if they have lots of people using a given stack, it's going to really help you first know if the model is really helping, because I've been in research a long time. One huge plague of research is like people overselling their things. So you read a paper, you think it's the best model ever, and then you try it and it doesn't work. And it's like everyone, it's not usually researchers being dishonest, it's often them dreaming and having their own thing that they've optimized for that benchmark, and that actually is very specialized for this application they have, and it actually doesn't work as well for other things. So for that reason, it's often a lot more promising to use something that has been tried and tested by lots of other people, rather than something that looks like it could be best, but you'd be the first one to use it. So I would say, look at what other people are using and be a sheep and be happy being a sheep, because sheep is good. Sheep is lots of people running to things, so if there's one wolf, someone else will take the wolf, not you.
So the takeaway is be a sheep, yes.
I love sheeps. If you like Wallace and Gromit, they're awesome. I'm a proud sheep.
I want to jump in on the community aspect of this. Maybe there's some Numberphile fans in the room, I don't know, but there was a recent video they released where someone on one of the podcasts was like, mathematics is a social activity done by nerds. And in the same way, I think machine learning is a social activity done by nerds. And so on the community side of things, whatever we can do to stay collaborative and keep moving forward, I think is going to be the place where the momentum is going to be, for the foreseeable future.
I would definitely second that. I think there's power in collaboration and open source. Things are happening really, really fast. There's a lemma coming out one day, and the next day someone fine-tuned it to a 100K context window. I'm making things up, but I think that's pretty much what happened. There's really, really a powerful aspect in community, and I'm happy that it's happening on Twitter, it's happening on Reddit, it's happening on Hugging Face. There's so many places where people are actually collaborating to make things better and really pushing things forward.
That's why I feel like open source is so great, because it creates that community, makes it possible for people to do the experiments and compare notes. And it's awesome, even if you go on Reddit and local llama, it's people doing this Frankenmerge. It's really fun to see, and it creates this new knowledge. And that's only possible because so many people are sharing those insights and those foundations of what they're using, the bricks.
So undoubtedly, we have an open source panel here. We have an open source event here. We are all along open source. But I have to say, there's almost some open source competition going on, right? We got Mistral, we got Llama 3, maybe Llama 400B. We'll see how soon that is. What does this mean? And put a bit more directly, who wins? In 5 years, who do you think is sitting here from the open source ecosystem that has either made the largest contributions and ultimately has the best model and tooling? And I'm going to start with you, Ilan, and hear what you have to say.
So I mean, who wins? It's like it's a very wide field. So it depends what your application is and what you're trying to do. So one model might be like faster and better for specific application you want to do, and another one might be better because it's perhaps slower, but it does exactly what you need. So it really depends what people are trying to do. Which again is why it's good to pick something that other people are using, because then you can see where it works for them, where it doesn't, and that gets you a guess of what would be the best stack for you, if other people have done it already. So who wins? I think there's room for more than one winner. Also because
But if you had to choose one, you know.
what? Yeah, but no, I don't think there's going to be only one, because I don't think it's necessarily winner take all. Just also because it also, I mean, if you think of it a bit like selection, if you have only one solution, it becomes super vulnerable to attacks and things like that. So I think it's good to have a solid, robust diversity of approaches and try to keep that, so that if there's an attack that suddenly works on one model and the other doesn't, then you don't suddenly have to stop all operations and you can just switch to another model. So I know, sorry, I didn't answer your question, but.
Yeah, I'll actually answer. I think well, I mean, beyond the obvious that Nomic's going to win, I think if nothing changes, then the cloud providers win. And, you know, I think we learned this lesson, you know, releasing the first Nomic embed model. You know, the only people that actually made any money off of that model was like AWS, because people downloaded it and like ran it on computers owned by AWS. And so one thing we're thinking really hard about here at Nomic is like, okay, well, we made this model, like clearly a lot of people in the community got value from it, and perhaps they're the real winners at the end of the day, as long as open source continues. But if we want to be sustainable, we have to figure out how to make it so that we're not just like effectively like driving compute to the hyperscalers. And so that's one thing I would love to see change within the open source ecosystem. And I actually think Hugging Face is in a great place to do this, is some kind of marketplace where open source model makers can bring their tools and, you know, get some kind of like compensation for the compute that those tools drive. Not to put you on the spot or anything like that.
Like Hugging Face is definitely benefiting from open source, and we're very happy about that. And we're also very happy to push open science open source. Like, to answer your question, I think like application layers are going to win. Competition is good. I think competition is healthy. Like, it provides more alternatives to people who are actually building on top of these foundational models. And so when you're a builder, having different many options, I think just like brings healthy competition, and it pushes the foundational model players to actually innovate and to bring down the price down and all of that. I think on the flip side of that, for the application players, like as the model progresses in terms of performance and capabilities, like I think it's very important for them to really think hard about the value proposition they have. Like, what happens when GPT-5 comes out and like what you were building, like it does it out of the box? What happens when Llama 3 400B or Llama 4, Llama 5, whatever, comes out and you're just like, the thing you've been building on for like 5 years, like just is out of the box? And it brings the question of defensibility. Like, how many weeks would it take someone else to build your product? And so I think like it's going to push a lot of people like to really think hard about that question of what is exactly the product I'm bringing, and how does that play with the technology progressing very, very fast. And so I think there are three axes where things are going to play out. The first one is go-to-market strategy, distribution and adoption, essentially. The second one is UI and user experience, so user interface and user experience. Like, you're building on top of tech, but that you're actually making like very easy for your users. And the third one perhaps is around data flywheels. Are you building modes that actually protecting your business and your company? So people are using your product, can you generate data so that you can reintegrate that data into the next generation of your tech?
Awesome. Well, it's an interesting point, back to Brandon's point on who benefits. Like, we love the Series A of Hugging Face at Lux, and in many ways, I think Hugging Face does benefit from almost being like a toll road for people using models, and a lot of the revenue does come from the hyperscalers, and so it is interesting. On the other side, we have a company called Together AI, which is doing a lot of like open source infrastructure stack can actually compute outside of the hyperscaler. So it'll be interesting to see how that whole competition evolves. Gonna switch gears a bit into multimodality. We've seen a lot of really cool multimodal models coming out, audio stuff. We had our Cartesia launch last week, a lot of stuff in video, a lot of stuff across the board. Love to hear a little bit of how you guys are seeing multimodal models in production. What are the unique challenges you're seeing from customers? Diffusion versus autoaggressive models, particularly in audio. I'm gonna throw it to Brandon first. I know you had a very exciting multimodal launch just today.
Yeah, thanks for that. Today we released Nomic Embed Vision, which is a multimodal sort of extension of our very popular Nomic Embed text work. And the thing that is sort of transformative about that model is it allows you to take your images and your text and put them in the same vector space and still get really, really high performance from that vector space for things like retrieval augmented generation, for downstream inference tasks. And I think this is a general trend that we at Nomic are really excited about, is the idea of taking all of the sort of unstructured content in the world that is being produced by these models and on the internet, and sort of as Leland said earlier, building one sort of unified way for computers to interact with that content. If I peel back what's happening here and think about what are the actual exponentials we're riding, I very much see two. One is flops, and Jensen wins that, and so good for him. But the second one I think is going to be data production. And so, and this actually gets one of the themes of the last panel, which is like, oh, are we running out of tokens? Like, what's happening here? We've just given everyone in the world the most efficient unstructured data producing engines ever engineered by humankind. We're not going to be running out of tokens. We're going to have so much data running around, we're not going to know what to do with it. And so systems for representing and manipulating that data, I think, are going to be increasingly valuable in the very near horizon.
Victor? Because you've been seeing a lot of interesting multimodal models on Hugging Face itself, right?
Yeah, I think it's very clear, to me, what the research in very big tech, like big AI labs, is going to look like. Essentially integrate as many modalities as you can, so images, text, video, audio, both on the input and the output side. A lot of people are working on it, and they're like billions of dollars that are being invested in that. And I guess our mission here at Hugging Face is really to democratize these type of models, and what we care about is really pushing for open science. And a lot of our work has been around essentially demystifying what it means to build such kind of model. So my team was mostly work on multimodality. We pushed this model called IDFX based on a dataset called Obelix. And beyond the model and the dataset, I think the most interesting artifacts that we're sharing is how we're creating these artifacts. What are the secret recipes that you need to build? Like what are the struggles you need to face and all of that. And I think like in the long run, I'm much more interested in like sharing these kind of like technical knowledge, so that more people can actually build these kind of technologies, rather than being like concentrated in a few actors or players. Because I think like the future is really about having more people building AI rather than being AI users. And I think like this is really part of our mission at Hugging Face, like to making these things like more accessible and more democratized.
Well, I mean, for me, what's really interesting with multimodalities, humans, they are multimodal, we have multiple senses. So it means that a lot of the data that we produce and how we interact, we take advantage of that to not be too redundant. So often, if you get some data that's produced by humans, it's not going to have everything spelled out because you have the image. And so there's kind of something missing if you only keep one modality, some like latent information that you wouldn't see. And so using this multimodal models allows you to allows you to access that data, and that perhaps has the missing part that was making it harder to reason. But once you get these other modalities, you can get to that meaning and get richer models. But I don't think that means that everything's going to be multimodal going forward, just because if you have a model that does everything, it has to be bigger. And in some cases, you're not going to use those modalities. For example, if I'm in the subway, I don't necessarily want the phone to be talking at me and telling about like my deepest secret and just like blasting them out. It's like, no, just give me in writing, I don't want to talk right now. So depending on circumstances, or if you have glasses, something like this, like you don't want everything to always be multimodal, and then it runs into this thing where sometimes what you want is to have something that's a single modality, but really, really tiny, so that it can be embedded. So I think we're going to get more into a constellation of models that are optimized for a given use case. So in some case, you get richer training with multimodal information, and that way you can take advantage of all the data you have and try to squeeze out all the meaning that you can. But we're still going to see very specialized models that are like one modality for a very specific use case that it does perfectly as like tightly as you can.
Wait, you don't want to build AGI?
What?
You don't want to build AGI?
Well, I'm saying perhaps AGI doesn't
just
fit
kidding.
into an earpod, and I need something in my earpod right now, so you put AGI somewhere else, like a little bot that walks with me. I don't know.
Look, all I know is, you talked about turning off modalities. Sometimes I'm in the subway and I wish I could turn off my smell modality. That's the big takeaway there.
Well, we do have a company, ML for olfaction, I was with earlier. Anyway, transitioning, different models, also different hardware and software architectures. So talk about experimentation you guys have done with non-GPU hardware, 4090 CPUs, and new architectures, Striped Hyena, Mamba, et cetera, SSMs. What role do they play in the ecosystem? Have you experimented with them? And if so, how are they using them?
Yeah, I think Apple did a really fantastic job here investing in the M series of processors before the ChatGPT moment. If I look at what the GPT for all models run best on, it's always MacBooks. And so I think where we're going to see hardware going, especially for personalized sort of AI use, these private sort of LLM use cases, think like diary apps or like even for like mental health pals as well. Like, you don't necessarily want to be blasting all that information to Sam and the gang up on Sand Hill Road, and so it'll probably be running locally. And so I think chips like the M series that have this sort of like weird, they're like not quite a GPU, but they have this integrated memory and they have like tensor cores style architecture, but going to become a lot more popular and proliferate very widely through not just the laptops, but like cell phones and these personalized devices more broadly.
Yeah, I definitely agree. I think there's a huge opportunity here for other players to build like different kind of chips. Like it's very obvious that NVIDIA is capturing like the good chunk of the market these days and a good chunk of the attention. But I think like there's definitely an opportunity for like more efficient architecture, more efficient chips that are actually running like models on the edge, like on device. And I really agree with like what Ilan was saying. Like the next wave of models are probably going to be very, very small and running on your phone. And I think it makes sense for players like Intel, Qualcomm, like Apple to really invest in that kind of thing. Models running on the edge. I think there's also an opportunity for models like that are not like heavily optimized for transformers. And perhaps like there's also an opportunity here for different kind of chips, training versus inference. Like a lot of the chips are really built for training these days.
We're here building right here in New York, right? A lot of people talk about San Francisco and AI, and New York is a huge AI hub. I think the testament of this incredible, both of these panels, as well as the audience here tonight, is a great example of that. Two questions around this. What do most people get wrong about building in AI in New York? And then second, talk a little bit about what needs to happen to make New York and continue to sustain this fantastic energy right here.
Well, I think one great thing about building in New York is it's a very diverse city that has lots of people, lots of professionals of different stripes, and so there's a bit less of a risk of being trapped in a bubble where you think something you're doing is great because it has a lot of echo and you're not rubbing shoulders with other people. I think New York has a bit less of that. Of course, it's still like a slightly homogeneous city. Like it's all people who chose to be in New York often. But I think it's compared to San Francisco, it has a bit more diversity in terms of like what people do. So I think that's a great advantage for people who are building like in consumer, like we're doing, and like not getting too trapped in those bubbles. But I mean, like I feel like one thing that we need is a critical mass of talent and things like this, and I do think we have that in New York. So as long as we have that, then I think we can get the like both a good density of talent, clients, thinking people, and still have this diversity. That's why I love New York.
Yeah, very similar sentiment here. Like look, I lived in Hayes Valley for a year, at Berkeley for a year before that, and chose to come to New York. And I think about the conversations I've even had this evening versus like when I'm in SF and it's like I've met the third AGI doomer in a row in like someone's Victorian house party, and it's like, oh my God, like someone be original, please. You know, and then there's also the aspect of there's more than just SF in the world. Like Paris is this insane up and coming AI hub, and like it's a much shorter flight from Paris to New York than it is to Paris to SF. Like in like Berlin as well, and you know, I think having a perspective beyond just the US and looking at where the rest of the development is happening and triangulating what's in the center of it, like even geographically speaking, it's New York.
Piggybacking on that, I think it's important to give credit where credit is due. Like the reason why, one of the reasons why Paris is such a booming place for AI these days is that 10 years ago, Yann LeCun and Mark Zuckerberg decided to open Facebook AI research in Paris. And all the big tech labs went to Paris opening an AI lab. And we're really seeing the fruits of that today. Like all the hot startups in Paris, like Mistral, QDI, H more recently, are coming from, like a good chunk of these people are coming from the big tech labs. And so, like, drawing the analogy to New York here, like all of the big tech labs have very strong presence. All of the hot AI startups also have presence, Hugging Face, Runway, Character. And so, like, I'm very confident that something similar can happen. Like Ilan, I think, is one of the example of these researchers that have been bred doing state-of-the-art research for so long and leaving to build their own company. And so I'm very confident about like New York being a place for AI. And perhaps the second thought is that to piggyback on what Ilan was saying, talent is here. The finance industry has been historically very big in New York. The fashion industry has been historically very big. Marketing also very big. And I was discussing with a friend the other day, and he works in a hedge fund. And you know, in the hedge funds, there are people optimizing to the milliseconds, like how fast your algorithm runs, because when you're doing high frequency trading, it really matters. And that type of skills, I would be very happy to hire someone for that. Like this is typically the type of skills we want when we're spending millions to train the next model, like optimizing very, very low level stuff. And I would encourage these people to come work in AI. I'm obviously biased because like, I do think that AI is like the biggest technology progress in this decade. Like we're talking potentially about disrupting the search market here. But if you have friends working with this skill, like bring them to me, I'd be happy to hire them.
He's hiring. Going to finish with a few hot takes as we wrapping and continue this conversation. First, and keep these responses pretty short if you can. What is the most overrated either AI company or AI research innovation today? Who wants to go first?
Underrated.
Overrated.
Overrated.
Underrated's next. You can start with underrated if you want. We can come back to overrated.
Underrated. Well, I'll do overrated. Look, I mean, just on a pure valuation standpoint, I think the XAI round was a little heinous, but like, I mean, we'll see. Like, if someone can pull it off, it's Elon. So, but yeah, that was a really, really large round. I was very surprised to see it.
Elon?
Pass.
Okay, underrated if we don't have an overrated. Victor has one now.
Overrated. I think I'm a big believer in the fact that at the foundational model layer, open source is going to win in the long run. And so I'm seeing all these very big rounds for foundational model providers, and I'm raising eyebrows. Underrated. The Chinese labs, I know it's a very controversial topic, but the Chinese lab have been putting out like very, very good research. And I think like it's, like we're doing a bad job in the Western countries to recognize that. Like some of the releases from Chinese labs are going kind of like going under the radar, but they're putting a very good job.
Underrated.
Underrated's tough, because it's easier to be a hater.
Could be research too, if you're not sure about a company.
Yeah, I mean, from a research standpoint, I love all of the work that's coming out of the mech-interp world, and I know it's like getting hotter, especially with the recent Anthropic release, but there's some labs at Stanford in particular that are doing a lot of work on the geometry of embedding spaces that I think is going to be incredibly important, and that's not getting the attention that it deserves, so.
Elon, bring us home. Underrated.
No. It's like I have too many friends in the space. I don't want too many enemies or anything. So.
With that, thank you guys so much for an awesome panel.